Hello. Have you wanted to do a secondary port calculation, and have you ever thought, is there a nice easy way we can do this? And there is. We have a nice logical way for you to be able to easily do your secondary ports, and you'll find this method works really well in all situations. So I'm going to use an example from an RYA Yachtmaster syllabus on page 36, question 10, part A, and this is Endal Marina, so it's a secondary port height calculation. And the first thing to do is to look in the training almanac and find where this secondary port is. We find that it's on page 64, so we make a note of the secondary port and the page number that we're looking at. And then we go to page 64 and we have a look at the information about the secondary port. It tells us the location and the standard port. So that's really important. We want to know the standard port. Standard port in this case is a fictional port of Port Fraser. So I'd also make a note once we found the page numbers for Port Fraser. So those are on page 48 to 51. Make a note of that. We'll make it easy to find it as well. And then just to make almost a shortcut, we'll check that this is a high water curve, because then we'll only need to adjust the time of high water, the height of high water and the height of low water. So what we need is a lovely logical method for this, and we'll make a few notes of what we're looking at. We're given the date as the 2nd of February. And the question is asking us what is the height of tide in the secondary port at 1700 UT. Now, just ignore the 1700 UT. We'll see that a bit later on. First thing we need to look at then is our standard port. Port Fraser. And we know that we're looking for the high water time, the height of low water, which will give us the range, we'll do this in a handy little table just to keep everything organised. Second of February is where that page number comes in handy. It's asking about 1700, so we're going to have a look at the tidal window with the nearest high water and low water. So there's a high water at 1502 UT. And the following low water is 2051 UT, so that surrounds the time that the question asked us about. That's the window that we're looking at. We don't need that time of low water, remember, but we do need that high water height. So we're going to make a note of that, 4.2 metres. We're going to make a note of the low water height of 0.7 metres. Calculate the range there, which is 3.5 metres, high water minus low water. We're going to have a look at that, and we can see that that's somewhat intermediate, but certainly closer to springs than neaps. So we're going to be much closer to the red line on the curve in the almanac there. So as we saw before, for a secondary port, we need to make adjustments from the standard port to work out our high water heights and times in the secondary port. And those adjustments are found by looking at the table for Endal Marina on 64, page 64. It's handy making a note of those page numbers. So here we are, and we are looking at a high water time of 1502 UT. Now the corrections table shows us high water heights and times with the adjustments. The high water times, if we had high water at midnight or midday, the difference would be minus 42. If we had high water at 6 in the morning or 6 in the evening, it would be minus 17. So 3:02 in the afternoon lies somewhere between 12 o'clock and 1800. So we're going to draw a line between 1200 and 1800 with 6 even intervals. Now we need to measure these really with a ruler or use some graph paper to make sure that they're accurate. I'm just going to draw them freehand for the time being so you get the idea. And if we had a high water time in our standard port of 12 o'clock, the adjustment would be minus 42 minutes. If we had a high water time in our standard port at 1800, then the adjustment would be minus 17 minutes. So we need a line that goes from minus 42 to minus 17. So if we look at the interval between those two numbers, minus 42 and minus 17, the interval is 25 minutes there. So there's only one way we can split that up sensibly. I mean, we could do 25 individual notches, which would work out fine. Or we could do one notch 25, which wouldn't be very useful. So I'm going to go for 5 notches, each 5 minutes long. And draw that using a ruler again. So we're going to have to mark those off. You could use an inch for each of these, or perhaps 2 centimeters, depending on the size of the piece of paper you're working on. 1, 2, 3, 4, 5. There they are. So that's going to give us minus 37, minus 32, minus 27, minus 22, and the minus 17 that we just saw there in the almanac on page 64 there. I'll just get rid of the end of that line so you can see quite clearly. Between 12 o'clock, 1800, the adjustments are minus 42 and minus 17. Now, the idea of this is that we can connect this line to this time from this adjustment, and then any times here, we would draw in a line parallel to that line, which in this case would draw up here, giving us an adjustment there, which we would then interpolate in between those 5 minutes to give us an adjustment in Endal Marina of minus 30. If you draw it accurately, you should get minus 30 minutes exactly. You can sort of see here, well, that's each of these is 5 minutes, that's 29 and a half, so it's leaning towards minus 30. Parallel to that, drawn accurately, will give us minus 30, and that therefore is 1432 UT. And we'll leave it there. I would normally put a little box here because we would need to have a think about DST at this point. Not applicable in this question, but if it was a question involving DST, this is where we would put it in. Now we're going to adjust the high water height, and that's 4.2 meters. We look at our corrections table again, and we can see that if the height is 4.2 meters, then that happens to be an adjustment of plus 0.4. So this is one of those lucky coincidences where our high water height falls exactly on one of the numbers given in the table. These are the high water heights and these are the low water heights. Often it would fall in between the two, and we would need to use the crocodile method or a mathematical method to calculate the adjustment. Looking at the low water then, we've got 0.7 meters. Well, we can see that 0.7 meters is not one of the numbers given for low water. It's somewhere in between 0.4 and 1.1. So if we're looking for somewhere in between 0.4 and 1.1, I would suggest that we put 7 even notches along here and mark those off. Along the bottom there. My personal preference is to go left to right and have the numbers increasing. It's a more logical method, but there's nothing stopping you putting 1.1 here and 0.4 on the other end, so long as you then make a note that your 1.1 is actually an adjustment of plus 0.4, and your adjustments will then go down, whereas doing it this way, our adjustments are going to go up, because 0.4 meters, the adjustment is 0. 1.1 meters, the adjustment is plus 0.4. So I need a line that can cover between 0 and 0.4. So we're simply looking for 4 notches, evenly spaced, which we would call plus 0.1, plus 0.2, plus 0.3, plus 0.4. I leave the pluses in there. It just helps to remind you that these are low water heights and that these are adjustments. When we connect those two together and draw it in parallel for our 0.7 meters there, we can see that we are closest to the plus 0.2 there, which helps us to naturally do the sums and gives us 4.6 meters for our high water height and 0.9 meters for our low water height. So what we do with them is we put them into the curve for Port Fraser. For the high water time, 1432, goes right here now. Make a note that it's UT, it'll help you avoid mistakes. Then we put the high water height from our secondary port, there it is, 4.6. Somebody else has already used this almanac, so I'll just get rid of that line. The scalar line, we call that, 4.6, and the low water there is 0.9, so we're going to mark 0.9 here on the low water axis. And then we're going to connect those two together using a ruler. I'll try to do that where you can see it. 4.6, 0.9, there's 4.6, there's 0.9. Here's our scalar line, and 1432 is our adjusted high water time. So in a way, you could cross that out now and say this is not Port Fraser, this is Endal Marina on that particular day. And this is something we could use on that day for pilotage, working out a height of tide at any given time. So back to the time that we were asked for in the question, that's 1700 UT. So there's 1432 there in the centre. Oh, actually, I've got it in the wrong place there. 1432 is there. So that'll be 1532, 1632, 1732. So in any event, you can see that 1700 is pretty much right there on that line. So we follow that up. We've already assessed that it's springs. That goes to this point here. I'm just drawing a line, or just drawn a line. So 1700 UT, we're going up here to, up there, if you can see that, where it hits the spring curve. Keep it nice and straight across to your scalar line, and then you can read that up or down there. And I can just show you that that comes out as 2.9 for the height of tide in the secondary port. At 1700, 2.9 meters. Easy, yeah? Then it asks us, what's the depth of water over the sill at the entrance? And we then need to have a quick look at Endal Marina, page 64 there. And we've got a chartlet, and it can show us a marina, and it can show us the sill, or the build-up of material that's been allowed to collect and stop the water, to preserve the amount of water in the marina there. They often have a bit of a sandbar that's intentionally left to sort of keep a bit of that water in the marine. But you see there that it's a chart datum of 1.5 meters. So there's always 1.5 meters on that sill. And if we've got a height of tide of 2.9 meters, then the depth of water over that sill is 4.4 meters at 1700 UT in the secondary port of Endal Marina. Simple, yeah? We'll have a look at more of these, and I've got some videos that explain the mathematical methods that you can use instead of the crocodiles.